Hello and welcome back to another intermediate JavaScript tutorial. This episode is going to be on web workers, which is something I've taken a bit of an interest in the past few weeks, and so I'm really excited to talk about this. Now, if you do find any of the information on this episode useful, feel free to subscribe as well as like and comment to help grow the channel. Alright, let's get to it. Alright, and as always, all of the material for this episode will be available on my GitHub. I'll throw a link in the description. In this episode, we're on the directory number 9 for web workers, and just as a note for that, because web workers take a file path that's from a server and aren't allowed to access your system file directory, you have to view a file from the server, and you can't just take a static HTML file. So, a really quick workaround for that I found is just to install the HTTP server from npm globally, and then run HTTP server period from inside your lesson 9 directory. And then you can open it up on your local host, which should be at 8080, and if it's different, it'll tell you in the console. And then we're just opening up this www.html for web workers. So, what are the basics? Now, if you watch the episode I did on the event loop, then you'll know that JavaScript is single-threaded at its core. But now web workers are a way to handle multi-threaded workloads. They're used as a tool by the main thread to offload those heavy workloads. And that's what you see in the picture here. We have the main thread running with the browser, and then it's able to communicate with this web worker through messages. Now, I think a good way to think about web workers, if you're trying to understand them conceptually, is like doing math homework with your really smart best friend. Now, I'm not saying you should do this, but if you were to do your homework by yourself, you would be reading off the question, thinking of the answer, and then writing it down. And that would be like the traditional way of doing things in JavaScript. You have one thread, you can be doing one thing at a time. On the other hand, your best friend could be viewed as the web worker. You're still responsible for getting the data, reading off the question, and eventually writing the answers. But instead of taking all the time to think and then write, you could read him all the questions, and then he spits out the answers, and you're just spending the time writing them down. And so instead of bottlenecking the homework process by thinking of those answers on your own, he's taking that heavy computation. He's not able to write it down. That would be cheating, and you're the one doing what in JavaScript terms would be the DOM manipulation. Don't cheat. So let's look a little more at how web workers are used. Web workers have self-contained global scope, and as I said, may not access the DOM. They're instantiated with new worker and then given a file path. A web worker then communicates with the main loop via events, namely post message. So if we look at a basic message example, we have our main.js and then we have worker1.js. And in our main.js file, which is going to be the file loaded into our www.html, our example1 creates worker1 with new worker and then worker1.js. The // is because it's in the same directory. We're then logging out. Let's post a message. And we're posting a message to that worker. Now, in our worker1.js, all we're doing is saying on message, and we're saying do this function, which is taking the event. We then have access to our message with event.data. And so if we run example1, let's post a message is from our main.js. In our worker1, we see we've received a new message. This is a message posted from our main thread, which is the message that was passed in our main thread. Now this is great and all, but if we look back at our homework example, this would be like telling the friend all of the questions, but him not being able to respond back. So let's learn how to talk back. Web workers have the ability to send message back to the main thread. They access their global scope via the self keyword. So if we want to post a message, that would be self.postMessage. And you can also send objects, which gives you more flexibility. If you want the worker to be able to do different types of computation, it can be helpful to define out a way of communicating between the two. So in order for the main thread and various web workers to communicate, both will need to define an onMessage and postMessage functionality. In the main thread, these will be defined as a part of the already instantiated web worker, and they will be specific to that web worker. And in the web worker, they're going to be defined as a part of self. So here we are at the main, and it might help to look at the bottom half of this first. Here we see example 2, we're creating our new worker 2, and then we're initiating the event handling. After that, we are posting our message, which is an object that has the attribute type of getNumber, and then we're posting another message with the type getGreeting. When we look at our init event handling, we're just saying take that worker and give it the onMessage, which is going to get our data, and then log out data.type and data.message. Now this is a convention that I made up just for this example. You could do whatever you want. And so this means when I'm writing my worker, I now have to keep in mind to pass an object that has the attributes both type and message. And so if we look at our worker, again, we'll look at the bottom part first. Self.onMessage, and as you saw in the first example, this could just be onMessage. And even here, it's in the global scope already. And so this is just clarifying that, yes, it's a part of self. But we're taking our data, and then we're just going to handle that. And so our function that's handling it is taking our data object, and we're checking for the type. If the type equals getNumber, post a message back. If the type is getGreeting, post a different message back. And in the case of number, our message back is going to be the type number back with a message getRandomNumber. And if we're coming from getGreeting, our message type, we're going to pass greeting back, and our message say hello back. And just for some extra clarity, if we look at our worker 2, I define these functions say hello back and getNumber, and they're just arrow functions that return a random number or hello world. So if we run example 2, we see, let's ask for a number, let's ask for a greeting, which is what we see in our main. Then our worker is receiving a new message object, the first one getNumber and then getGreeting. It's then responding, and our main received a message of type number back with the message 4 and greeting back with the message hello world. And now if we run that again, we see that it is a random number. So it's running that function, it's making that calculation, and giving a result back. So at this point, we've kind of covered what you can do with them, but how are they used in real life? As we've kind of talked about, large data computations is a main one, but you're also able to do background I/O, and I/O stands for input output. In this case, it generally refers to communication with the server. So if you need to do a large database update, or you have to upload a massive file, that's something that can take time, and this allows us to do that without blocking the main thread. There's also something called polling. Now, if you wanted to write a chat app, you could use WebSockets, which is event-based communication with a server. But before that, you would use polling, which is asking on a set interval if there were any new updates. So you might ask every 5 seconds, did I get a new message? No. Did I get a new message? No. Did I get a new message? Yes. Okay, handle it. In this case, it allows us to move that functionality out of the way and not have to worry about it until we're told, yes, there is a new message, and then we can handle it on the main thread. But for a good practical example that I think is not too complex, let's compare this to the calculation that was done in our lesson 5, which was on the event loop. Before web workers, we could only rely on async computation to make large calculations without blocking that main loop. And so if we go to that file, what we were doing was calculating 0 plus 1 plus 2 all the way up to 500 million minus 1. And if we run that, try clicking just say hi twice, we find it doesn't work until that computation is done. We get the result, and then it handles those buttons because that was synchronous code, meaning it was blocking the main loop. Now we came up with smart async, which allowed us to take the button, press it, because it was doing bits of computation at a time, and those were handled asynchronously, which means they were taken from the queue, and when the stack was available, it would do some more calculations. Then it would do some more intermittently. Now, obviously, it's a little bit slower, but also it's just kind of a clunky workaround because you have to write in a bunch of logic, and even at that, you're given the trade-off. Do I make larger calculations, which are going to be faster, but it's going to spend more time blocking? Or do I do a bunch of smaller calculations, which is going to be slower, but then it gives us more flexibility? Thankfully, using web workers, you don't actually have to decide between the two. And so that's what I implemented here, where we say when our calc button is clicked, create a new web worker, worker3.js, get the start time, and then we're just going to post a message of what we want to be calculated. And then on our message, figure out what our end time is, as well as log out what our result is. For our worker, when we receive a message, we're just going to do the same loop that we did in the synchronous calculation. And when we get that answer finished, post that message back. Now it's kind of funny because I created the same start counting that we had in our lesson 5, where we just count to 10, thinking that this will help show that it's able to still count while a calculation is being done. But what's crazy about this is it's actually difficult to do that because the calculation is so fast. Now I was able to time it just right here, but we see beginning calculation, and then we get that calculation about a half second later, which is insane. What was taking us basically 6 seconds on the main loop is being calculated in just 10% of the time by using web workers. And it's not blocking the thread. So we're getting the best of both worlds. It really is crazy. And the main reason for this is that especially as computers get more and more advanced, they have more cores available. And so instead of relying on the JavaScript engine to make these calculations, we're able to access more of the power that our computers have. So this really is a great tool of JavaScript. Now, what are my final thoughts? Well, as I literally just said, web workers are a powerful tool for keeping the main thread open. The main thread still controls the DOM, or the view, but web workers are a great way for computationally or time-intensive tasks. And I do think it is worth noting that this isn't an everyday tool for most web apps. I mean, most web apps have simple I/O, simple DOM manipulation. You just don't need to make massive computations. But I still think it's a good tool to play with and get to know, because someday you may run into that problem and you'll know right away that you've got just the tool you need to solve the problem. So, I hope you found the video useful. Like I said at the beginning, feel free to subscribe for more content like this. Likes, comments, they help grow the channel. And if you think web workers are cool, like I said, feel free to go to the GitHub, play around with it, create your own example. And the video cut out there, but I hope to see you again.